This is a geometry lesson on the trapezoid. First off, we'll start with the definition of a trapezoid. Trapezoid is a quadrilateral with exactly one set of parallel lines, as drawn here. We call the two parallel lines the bases. The ones that are not parallel we call legs. If the legs are congruent, then we call it an isosceles trapezoid. Okay, trapezoid. You know, that's one of these words that I just always have trouble remembering what it means. I mean, I know it's this thing and it's got its bases and they're parallel and all that kind of stuff, but in order to figure out trapezoids, I kind of needed to come up with a dumb story because I could not remember the word trapezoid. Okay, so let me introduce to you here Little Bunny Triangle. This is Little Bunny Triangle. Nice Little Bunny Triangle. So I got a story about Little Bunny Triangle. Okay, here we go. Little Bunny Triangle hopping through the forest. Okay, try again. Little Bunny Triangle hopping through the forest. Scooping up the field mice and oh no! Oh no! Little Bunny Triangle got caught in a trap, a parallel trap, and got her point cut off. So Little Bunny Triangle is now a trapezoid, having gotten caught in a parallel trap. Okay, so here's Little Bunny Triangle. So what do we have here? Two parallel lines and two lines that are not parallel. So one thing I look at when I'm looking at a possible trapezoid and I'm trying to figure out if it's really a trapezoid, I say, wait, can I see where Little Bunny Triangle's extra point used to be? Look at these legs and they come, oh, yep, there it is. There's Little Bunny Triangle's point that got cut off in the parallel trap. Okay, a few things more about trapezoids. Let's see. Okay, what if the Little Bunny Triangle that I start with, here's a Little Bunny Triangle. I'm starting with Little Bunny Triangle, and Little Bunny Triangle was actually an isosceles triangle, so I could mark that. So here's Little Bunny Triangle, right? Okay, and we all know that in an isosceles triangle, the base angles are congruent. We've already learned that. This would be the base of the isosceles triangle. The base angles are congruent. Okay, so what if the point that Little Bunny Triangle happened to have gotten cut off was this top point up here, the vertex of the, and it's cut off parallel because it's a parallel trap, and we'll just pretend that's parallel because I said it was. Okay, so it cut off parallel. Okay, let's think about that. Are the angles still the same? Yeah, I think they're still the same because I cut off the top. Those are the same. All right, then is this portion, this leg, and this leg the same? Okay, think back to your lessons on parallel lines and transversals, slicing them out. Remember where we had the bread slicing? That if parallel lines and transversals cross, that it will, the parallel lines will slice the transversals proportionately, which would mean, oops, wrong piece, which would mean that when we do that, it'll be pieces to pieces, pieces to piece, okay? Or pieces to whole as pieces to whole. Since the whole is the same, the left one and the right one, then when we slice it proportionally with parallel lines, parallel, parallel, then the pieces will be in the same proportion. Since the proportion of the whole thing was 1 to 1, they were congruent, then these must also be congruent. Okay? So what we have here is that in an remember in an isosceles triangle, if the base angles were congruent, then the sides are congruent. That was the converse of the base angles theorem. It holds here just the same. If the base angles of a trapezoid are congruent, then the opposite legs are also congruent. Now notice here with trapezoids we get an extra special we have two bases, and therefore we have two base angles. And these we can demonstrate pretty readily using consecutive interior angles or also congruent. So, 2 cut by a transversal at the same angle. Okay. Half is 180, half is 180. They both have to be the same. Okay. Another thing about trapezoids. Okay. If we have our handy-dandy trapezoid here, we look at it in an argument similar to the one that we just made for rectangles. Here, the diagonals are also going to be congruent. They won't necessarily meet at any particular angle, but they will be congruent. How could we prove this? We can prove this using lots of SSS's and A's and A's and A's and A's with the bow ties or with the hourglass triangles. Just work through that if it's not obvious to you and ask me if you have any questions about it. So there we have 3 theorems. Please pause and make a note of them. Okay. Then next up, get yourself a 3x5 card, or just some card that's a rectangle is fine. Get your cipher, and in your cipher, we're going to need to paste it in. First, we're going to make a trapezoid. Then we're going to paste it in. Take your straight edge. Don't just draw it. Draw it straight so your numbers will work. Take your straight edge, and at one lower corner, make a line to slice off. Make the other one different. It could be the same. It'll still work, but it's kind of boring. Take your scissors and cut it carefully on it. So that'll give you a trapezoid. In your cipher on the next page, it's all vacant. Take your trapezoid and paste it in. Paste it in so that the upper base is aligned with the red line. Now, there's nothing special about that except we're going to use the lines to do parallels and perpendiculars. And just go ahead and paste it in. I had to go get my paste. So paste it in so that the upper base is lined up with the red line. Now we're going to draw some lines. Start off, draw. Okay, all of your vertices are not going to be right on your lines from your cipher, but you can use it to kind of line up and see what's parallel. So now I'm just putting my ruler so that it's parallel, and at the vertex, draw your line all the way up and down. Draw your line all the way up and down at each of the 4 vertices. Try to get it as accurate as you can so this will work for you. Now once you do that, start measuring. And I'll show you all. First off, measure for you the length, and go ahead and mark it outside of it. Put little arrows like I'm doing here. Measure your length. That's the length of the bottom base, and now put the length of the top base. Put your numbers in there. Then also do the distance between these outside portions, and put in your numbers. Sorry about that. A little bit of delay. Computer issue. So go ahead and do that. And then take probably a different color and take half of whatever this is and calculate it out. Draw you a nice vertical line in your other color and mark what your amount is here. Put your amount there. Do it on both sides. Oops. So this will be half of what this one is. So half, so you split it right down in the middle, and you'll get that. Okay. After you do that, draw a line. Well, first off, let's look at what happens here. Right here, this was half of the measurement on this perpendicular line. Half of the measurements. Just look at this one. Half and half. That is equal to that. Notice that these are also equal. Why are they equal, you say? Well, let's think back to the parallel slicing theorems that we did previously. It's going to be proportionate. That is to that is that is to that. Since these are the same, these have to be the same so the proportion is equal to 1 over 1. Does everybody see that? I hope so. It will be the case over here as well. These are congruent, so these are congruent. If you would, okay, then let's state the obvious. That means that this is the midpoint. And this is the midpoint of the left portion. So go ahead and label that. And connect the midpoints. And this has a name. You might guess it. Think back to when we were doing triangles. We did the midpoints of the sides, and then we had the, oh, what do we call it? The midsegment. Indeed. This is the midsegment of the trapezoid. You might recall that the midsegment of the triangle was parallel to the opposite side and half the length of it. Well, that applies here, but not quite exactly. It is parallel, and we'll talk about the length of it. Here, do this calculation, just there somewhere on your page. Add up, take the average of the bases, your two bases, the amount that you measured, take the average, and see what it is. Then come in and measure the length of the midsegment. Go ahead and put that down here because there's too much of it. So put the midsegment length down here. The average of the bases, if you've done very carefully, should be the length of the midsegment. I have the length of the midsegment down here. Okay, I have one here that's all done with numbers, that way that my numbers are. So you should have it in your cipher like mine is, and you should figure it out. Now, when I did it, I came out with approximately 8.9. And I measured it as 9, so really pretty close. What did we find out here? We found out that the midsegment is the average of the two bases, the upper base and the lower base. We found out the midsegment connects the midpoints of the sides, of the legs of the trapezoid. And is it parallel? Well, let's see. Here we've got some parallel lines, the two opposite ones, because it's a trapezoid and it got caught in the parallel trap, so they're parallel. But we have here equal amounts. How would we know if that were equal? We did that in the last lesson, if you will recall, by showing the distance between the lines, and that tells us they're parallel. We have a right triangle here and a right triangle here. We use our theorems and sides and angles to establish that they are congruent, and the corresponding sides of congruent triads are congruent. So the distance between them is the same in each location. When the distance between two lines are the same, they're parallel. So this makes us a handy-dandy theorem, and here it is. Please make note of it. Okay, midsegments of trapezoids. Okay, another thing about the midsegment. Okay, you recall from triangles that if we have a triangle, we find the midpoints and join them, that's the midsegment of the triangle. And what we learned at the time, that the midsegment was parallel to the side and half the length of it. You say, well, that sounds awful similar. There ought to be some overarching concern here. Okay, well, let's think about it a minute. What if you think about this as a trapezoid with like a really, really small upper base? So small, it's not there. All it is a point. Okay, well, how long is a point? How long is a point? A point is 0. Okay, is this strictly true? Well, kind of, yeah. Let's see what happens here if we treat this according to the midsegment of a trapezoid theorem rather than of a triangle. Okay, so I've got this over here. Say this side length is 20 units. So I'll average my two bases. My upper base is 0 plus my lower base divided by 2 is 10. So this would be 10. Oh, wait. Look. And 0 doesn't make any difference, does it? So we see that the midsegment of the triangle is just a special case of the midsegment of the trapezoid. Divided by 2 because the upper base is not there. It's 0 long. So that would be this here, okay? So it's the more general theorem is the midsegment of the trapezoid. This is a special case that's very handy to be a special case. It's just divide by 2. It shortcuts your averaging. Not by a whole lot, but by enough that, hey, you might as well do it. Okay. So let's try some problems here. Okay. We know that's a trapezoid because the sides are parallel. It's a quadrilateral. The other two sides are not parallel, but they are congruent. It's an isosceles trapezoid, therefore the base angles must be congruent. This one's 50. Well, since the two on the left are congruent, the two on the right are congruent, and the whole thing is 360, each half must be 180. That must be 130. That must be 130. Or you can do it, work it around a little more complexly. Same deal here. Work around and find it out. You'll do the same thing. Let's look at this one. Is this a trapezoid? Both sets of base angles. If it is a trapezoid, these would be parallel, and these would be the bases. The angles at the upper base here, the angles at the lower base are congruent, therefore it is a trapezoid. Let's look at this one. Is this a trapezoid? Okay, well, we need two sides to be parallel. We know that two line segments that are perpendicular to the same line segment are parallel to each other. We learned that a long time ago, so the upper and lower are the bases, and it is a trapezoid. Is this a trapezoid? Let's see, parallel lines, but the other two cannot be parallel. These are congruent. Work it around. You'll see that it's not possible. These two have to be the same distance. Midsegments. What's the length of the midsegment? It's the average of the bases. It's 14. How do I know that it's a trapezoid? Because it says they're parallel. It says these are congruent. We got it going. Okay, that one's actually, yeah, okay. Same deal here. Average the two, and you'll get to where you're going. Okay, and here is the lesson.